Good day. My name is Akshay Jajanandan, student number ST10441329. In this demo, I will show how I factored the TechMove Logistics Global Management System into a service-oriented architecture using ASP.NET Core Web API repository and service layer patterns, HTTP client-based front-end communication, JWT authentication, automated integration testing, and Docker containerization. I will follow the marking rubric order exactly. So first off, we'll go to the Web API construction. I created TechMove Logistics grms.api. In here, we've got controllers, TTOs, repositories, and services. So part 3, I refactored the original app into a service-oriented architecture by introducing a dedicated ASP.NET Core Web API project. Previously, the MVC application handled database operations directly, and now the API is responsible for communicating with the SQL server, while the MVC application acts as a front-end client. This improves maintainability, scalability, and separation of concerns because the system is split into dedicated layers. Here we use the DTOs to transfer clean data between the API and its consumers. Repositories manage the database access and services and contain business logic, validation, and workflow rules. Okay, next we'll look at Swagger. Swagger provides OpenAI compliant interface that documents every endpoint in the system. It allows me to test the API directly. XML comments have been enabled. So endpoint descriptions, parameters, and response codes are shown clearly. So you can see the different sections. We've got auth, contracts, currency, health, and service request. The API now exposes endpoints for health checks, JWT, authentication, currency conversion, clients, contracts, and service requests. So if we first look at the auth one, I added JWT authentication to the API. The login endpoint validates the user through ASP.NET Core identity and returns a signed JWT token containing the user's identity and role. So if we execute this, we see that the API has returned this, and here's the token. We also see a 200. Sorry, here's the token, and yeah, we see the 200 response code. The token can be copied into the Swagger Authorize button, which is on top, and used as a bearer token. This demonstrates API-based authentication using JWT. So the next thing we'll look at is the health API. Let's go there, try it out, execute. We've got a 200 response, status healthy, and we can see the environment is on Docker. Health endpoints are useful because they allow monitoring tools or Docker to check whether the service is available. Next, we look at the currency API. Put in an amount, let's put in $10. We see it returns 200 and the amounts. It converts the US amount to South African rands and returns the result as JSON. This is useful because service request costs can be entered in USD and converted to ZAR automatically. Next, we'll look at the client APIs. The GET API clients, this endpoint retrieves clients from SQL Server through the repository layer and returns structured JSON data. HTTP 200 confirms that the request was successful. Next, we'll check the post. We'll put in some values here. Execute. I don't provide a client ID because SQL Server generates the identifier automatically. This prevents key conflicts and ensures each record has a unique ID. Here we got a 201 created, ABC Logistics, and if we switch to the MVC, and look at the clients, we see the new client has been added in. They are visible immediately in the front end, and this shows that the front end is consuming the API instead of reading data directly from the SQL server. Okay, next we'll look at the put, which updates an existing client. First, let's just get our client IDs. So we see our new client is ID 4. Here we change the name to AB Logistics. region, we change to JHB, execute, we should see a 204, and we do. And if we go into the MVC and refresh, we should see AB logistics and the region and contact have changed. Next, we go to the delete, and we use the same client we just created, ID number 4. We get a 204 response, which means the API returns the correct REST status code when a resource no longer exists. And to confirm that on the MVC, we see the client has gone. Next, we'll look at the contract APIs. The first one retrieves all the contracts from the SQL server using the API service and repository layers. If we run it, we see all our contracts in the system. Next, we'll create a new contract, the post request. So for client ID, we put in 1, status active, service level gold. We execute. I leave out the contract ID. The database generates this automatically. So here we see contract ID 3, and if we go to our MVC, refresh, we see here's our gold contract that we just created. Next, we'll look at the put request for contract IDs. We put in our new contract that we just created as the ID. Client ID, we'll use 1. And we're changing the status to pending and the service level to solver. Once we do that, we get a 204 response confirming that it's gone through. And then if we request refresh the MVC, we see that pending and solver have been updated. Next, we'll look at the patch status. Here we can update the status of contracts via the API. So contract status currently is pending. We can change it to active here. If we execute, we should get a 200 response. Here we go, and we see that it's changed to active. So if we look at the front end, we see that it's been changed to active. So this reduces unnecessary transfer and follows RESTful API design principles. Next, we'll delete the contract with the ID. So let's just go there, try it out, and we put ID number 3, which was the contract we created. Execute. We got a 204 response. And if we look at our contracts, that contract's been removed. Next, we'll just look at the PDF APIs. Let me just close these. Okay, so we've got post, get. These are to upload or download the original agreements or updated agreements. It keeps file processing on the back end rather than inside the MVC controller. So let's upload a contract. So we'll use contract number 1. Select the file, just choose this. Execute. We should get a 200 response. We see that the signed agreement has been uploaded. Next, we can download the agreement that we just created. If we go here and run this, we get a 200 response. And we have a link to download the file. There we go. File's been downloaded. And that works the same for the updated agreements. And we'll have a look at the service request APIs next. So first we've got the get to get all our service requests. We execute, we should see here's all our service requests. Next we'll do the post, which creates a new service request. Try it out. We need a contract ID, so we'll use contract ID 1. Description, active, cost 10, status, draft. So if we go into the front end and we look, we have this one service request. When we run this, we should have another one appearing. And there we go. We've got a 201 response. It's also converted to ZAR. If we come in here and refresh, we see that this contract has been, the service request has been created. So the backend handles validation, contract checks, currency conversion, and email notification logic. We can also update details of a service request by using this put API. We will use the service request ID, which the one we just created is 4. Contract ID is still 1. Description we'll change to draft 1. Cost we can change to 200. And status we can say pending 1. Once we execute that, we see our 204 code. And if we go into the front end and we refresh, we see it's changed to draft 1 and pending 1. And so is our price changed as well. Next, we'll look at the delete service request ID. So our service request ID we're working with was number 4. Now we're going to delete it. We try it out. Put in 4 as the ID. Execute. We get a 204 response. Service request deleted successfully. That's what that means. And if we go to the MVC and refresh, we see that service ID is gone. In terms of error handling, we can try and look for contracts that don't exist. So if I go here and I try service request ID 4000, you can see we get a 404 error not found. So when a resource doesn't exist, the API returns the 404 not found error instead of crashing. And this allows client apps to handle missing data correctly. If we look at a GET request and we put in a number, so request ID that doesn't exist, we also get a 404 error. And if we look at one more, let's just look at the okay. And if we want to upload a file that's different format than PDF, we get a 400 error, bad request. So the API validates file uploads and rejects unsupported file types, which protects the system from an invalid input. The API correctly uses REST status codes, including 200 OK, 201 created, 204 no content, 400 bad request, 401 authorized, and 404 not found. Okay, next we're going to move on to architectural integrity. We've got this contract repository as well as iContact repository. The repository pattern abstracts all entity framework operations behind dedicated interfaces. Controllers and services don't directly query the database. These repositories are responsible for retrieving and saving data. We have these different methods: get all sync, get ID by sync, add async, update, delete, which improves maintainability and testability because the data access layer is separated from the rest of the application. We also have these other repositories, and the same pattern is used for clients, contracts, and service requests. We have the contract API service now, client API service, and service request API service. The service layer contains business rules and validation logic. For example, contract workflow logic, PDF handling, email notification, service request validation, and currency conversion are all handled in services instead of controllers. And centralizing business logic ensures rules are applied consistently regardless of which client consumes the API. Next, we'll look at the program.cs. Dependency injection is used extensively throughout the application. Dependencies are provided through constructors, which reduces coupling, improves maintainability, and makes the system easier to test. This demonstrates separation of concerns. Controllers handle HTTP requests and responses. Services handle business logic, and repositories handle data access. And SQL Server stores the data. Each layer has a clear responsibility. Okay, next we'll look at the MVC project. If we look at services in here, we've got contract service, client HTTP service, and service request HTTP service. So now the MVC application communicates with the API through these HTTP client services. In these controllers, the client controller, contract controller, and service request controller, They no longer use application DB context for business data. Instead, they call services such as iContract service, iClient HTTP service, and iService request HTTP client service. During local development, the front end uses localhost. In Docker, this value is overwritten by Docker Compose, so the front end communicates with the API using the Docker service name. Okay, next we'll look at automated integration testing. I've created this api.test. We've got these three files. Integration test hosts the API in a test environment and send the HTTP request to the endpoints. This validates the full request pipeline, not just isolated methods. So let's open the Test Explorer. And run all the tests. The test suite covers authentication, clients, contracts, service requests, PDF upload and download, and status updates and error responses. The create then read test verify data integrity. A resource is created through the API and then retrieved again to confirm that the stored values match the original request. Automated integration testing helps prevent regressions and reduces the risk of deploying breaking changes. All our tests have passed. So next we'll move on to the API Docker file, which is in here. Sorry, let's go to API. This Docker file uses a multi-stage build process. We've got the SDK stage, the restore, publish, and runtime stage. Multi-stage builds separate compilation from runtime execution. Only the published app is copied into the final runtime image. This reduces image size and improves deployment efficiency. Docker layer caching improves build performance because dependencies don't need to be restored every time if the project files haven't changed. With this entry point, it automatically starts the app when the container launches. Next, let's look at the MVC Docker file. The MVC uses multi-stage Docker file as well, and this means both the applications have consistent build and runtime behavior. Okay, if we have a look at the Docker Compose YML, Docker Compose defines the complete application environment as code. We have different services, SQL Server DB, backend API, as well as GLMS front-end API, front-end web, sorry. These three are the required containers, and all containers communicate through a dedicated Docker bridge network using instead of using hard-coded IP addresses, Docker service names are used. Also see the environment variables are here, the connection strings, API settings, JWT settings, etc. Configuration is passed through Docker Compose environment variables. This means that configuration can change between environments without modifying the source code. If you look at our API settings base URL, this 8080, the front end communicates with the API using the Docker service name, GLMS backend API. And this demonstrates container to container communication through Docker networking. The API communicates with the SQL Server using Docker service name and SQL Server DB. Volumes. The SQL container uses a persistent Docker volume, so data remains available after the containers are stopped and started again. Okay, now we'll open the terminal. We've got it open here. Okay, let's just close that. Shut it down. Then we're going to run Docker Compose down and Docker Compose up build. This demonstrates the building and starting of the containerized solution using Docker Compose. These logs are showing the SQL database API and the front end starting up. This is Docker Desktop, so once the containers are running, we should see them appear here. And all three should be running simultaneously. the server is now running. And now we can see the back end and front end, the APIs, as well as the MVC.